Hello everyone, this is Arman, and today me and Rizwan Ansari is going to demonstrate about our deep learning project, and the title is basically we are trying to compare the performance of fake data which is generated by GANs over different machine learning model, and we will discuss what are the applications of GANs and how we can use synthetic data in industrial applications, and how GANs can be useful in real life situation. So before diving into the coding part and the theoretical part, I just want to take a feedback from Rizwan Ansari, like how synthetic data is useful in industrial applications as you are working uh, uh, in uh, in practical scenarios. How do you think, like, how we can use the GANs?
Hello, Arman and everyone. It's been great to discuss the very important topic, and this GAN is one of the like of a area where it can have a big impact in practical world, particularly like in banking or the organizations where data security is a very huge issue. Many organizations are suffering with that because like when they need to engage with the third party vendors and or to share the data outside the organization, they need they need they have a lot of data privacy, and these days, the data is like very important in banking level. State banks has many compliance restrictions of the bank, like bank cannot use the cloud services, such like that. So we also face such issues as when we were working with our external vendor for the model development. We cannot share that data. So GAN is literally the solution for that. And the purpose and overall concept of this project is to see that how GAN is effective and what method we can use to generate that tabular data, especially further like the CT GAN. GAN is useful, particularly in a deep learning side for the image processing, text generation. But CT GAN is one where it is widely used for the tabular data
Fair
generation.
enough.
And
Thanks, Rizwan. Yeah,
this is where the tabular
yeah,
data and
exactly.
everything is very significant.
And one more interesting thing I just want to add here, like uh many people know like how we sample the data from distributions, we estimate the joint PDF of the data, and we sample the data from different distributions. But GANs is, it's again a black box. It's comes under an umbrella of deep neural networks, which solve, different non-linear data sets. Like if your data distribution is very complex, like if you have bimodal distribution, extremely skewed data, and flattened data where you don't know the parameters of your distributions, then there comes a play of uh, these neural networks, which learns the density very effectively and generates very accurate synthetic data. So it's
Agreed,
very
agreed.
effective approach to sample data from.
Arman, just to add one more very important thing that, you know, for oversampling, for generated the sample to enhance your sample can be very effective. In terms of class imbalance problem, where let's suppose you have a portfolio which has two classes and one class is very oversampled. So you can generate through GAN, and you can oversample your sample to for the model building process or any other applications.
That's
And
great, Rizwan.
if I just to add, if I ask, the whole journey, can you explain that? It's fine. You generate that data, and if I say it should, in other words, it should not be exactly replication of the data as well, but how you explain the whole process of this, like GAN generator and distributor.
All right, that's a crux of GAN. That's how it it is not only just copying the data, it is just generating the new densities from the original distribution. So there are two different architectures in GANs. One is a discriminator and the second is generator. So generator is the source of the fake data, which tries to fool your discriminator, which has original density. So it tries to repetitively increase the performance of your data. So it tries to fool your discriminator, but discriminator has the original density, and it tries to minimize the error, and it tries to catch the fake data. So that's how they tries to combat with each other and tries to generate fake data. So there are two components in GANs.
Rightly said. Rightly said. Just to add one more thing that is fine. You have that your GAN, like you use the T-GAN to generate your synthetic data from real training data. But the question is, after all this process, how you can assess that either what you have generated is the right thing to generate. And just to add, like it's fine that you check the central tendency, you can check the statistics of the data. But I think what is important that you generated the synthetic data must capture the properties, exact properties of the original data. And can you more explain that how you can validate that thing and how we have done that done in this project to validate that?
Sure is one. So the performance evaluation setup is basically, when we illustrate the performance of your models. So we just sent an unseen data to your machine learning models, and we see how your machine learning models performs on your unseen data. So what we actually did, we built two different models. One is using the real data, and the second model is basically used the synthetic data. And what we actually tries to do, we compare the performance of different models, which is trained on real and fake data, and we pass the real data, and we check how the synthetic model is behaving with the actual model, so that we can we can measure the KL divergence between the original and the synthetic data. So how these two densities are close to each other. If the performance maintains, so we could see that your data is quite is efficient. Your GANs is able to capture the original distribution, and we will see that some of the models is not able to resilient against the slight drift in the data. So that's how we set up. We just build two different models. We run the machine learning pipeline, and we evaluate the different parameters like F1 scores for the classification problems and the R squared for the regression problem. We use five different data sets for this machine learning pipeline, and these data sets chosen from UCI machine learning repositories.
Thank you,
That's the
thank you, thanks
process.
so much. Let's move toward the coding part, which is not so much important because coding is
Obviously.
not really these days, but the concept is actually important. So coming to the coding point, let me have that brief that obviously you need that library. We have used NumPy, we have sklearn for the models, stars model, where FCC model, MLP is classifier for that the classification model, and especially for like for generating the GAN, we also use the GAN. I think it's on the below side.
Yeah. So we basically use
GAN
different
generator,
requirements.
the GAN generator, original GAN generator has been used as a library for the data set. And moving to the first data set, I think we'll cover one data set completely as a wholly. and then we'll
Yes.
come to the final results of all these four data set and five data
Yeah.
set we have used in the project.
Sure. So basically, let's start with the first data, which is a classification problem, in which we tries to predict the breast cancer by using different cell data. So there are multiple features, and we use this data as a anchor data to predict your density by using GANs. So this is a classification problem, and there are different data sets which will come, but in this video we'll try to just discuss a single data set. So this is the uh,
So good,
glimpse of
good.
your data.
We have good amount of variables. It's almost nine variables, and one is the
Yeah.
class where we have by class. Let's have that view that how we reach that generation of the synthetic data. So the helper function, they're starting from the helper function where we the generator and the hyperparameters of the generator is like the quantile, the learning rate, obviously how much then the batch size is important is through the batch process, and how much iteration you need to perform. Initially we keep it 1000 to generate.
Yes.
Further to the model evaluation part, that's your classification, all the models, build that function to call that for the performance evaluation. Moving to the next is the classification, where we have all this model evaluation for the regression problems, where we use R square for the comparative.
And we also use some helpful functions to to deal your categorical data, which is very tedious task. So that's why we just wanted to make it easy for the repetitive task. We build different functions for label encoding. This really helped us to prepare data for machine learning part. So that's another helper function. So before generating the data, we basically split the data into train test, and we pass this data as a requirement to generate your fake data. And you can see we have used early stopping mechanism here to enhance the performance of your data. Early stopping sometimes help you to avoid the overfit of your data. That's why we use here it. And this
Previously,
is
Arman, result is amazing on the first data set.
obvious. Yeah.
What we see, the classification result is also very good. Although the project is not about to achieve that score
Yeah.
for the prediction, but if we compare that result, the original one and the synthetic one,
Yeah,
so
sure.
that's showing that
This is
the actual
amazing. This is
it's pretty
amazing.
it's pretty captured. It's pretty captured the original properties of the real data.
Yeah, you can see the support vector is achieving 97% recall for the classification for the second class, and 95% for the class 2. And similar to this, if we look at the fake data, and the performance is again maintained, and that shows that your synthetic data is quite resemble to your original data.
If you just compare the F score, because it covers the precision and accuracy,
Yes.
the both precision and recall. So that
Yes.
if we compare that F score of all these classification problems, we see that the result is not much deviating. It's very much near values we have achieved from the
Apart
original.
from, I think, multi-layer perceptron, everything is uh, maintained and the performance has been maintained. But a multi-layer perceptron, you can see the performance dropped slightly. Um, so maybe this model is not resilient against the change.
Can you show how much, how, although the performance is not that much, it's 62%, but can you show that how much is deviating from the original one?
So basically, if you look at the performance of MLP on the original data, it was 95%. and it has dropped to 62%. So
So that
it
that
is,
actually shows that MLP somewhere where once there is any deviation or noise in the data, that MLP could not give
yes.
that
The MLP is again, it's a very, simple or simple to you solve your simple problems. So whenever there is there is kind of drift coming into your data, then it is not effective to cap to maintain its performance.
Okay, okay, Arman. So that's part of the quantifications, how we validate our synthetic data with the one. But I think the
And
visualization is
Rizwan, one more
one
thing,
more
you can
important.
look at this beautiful distribution charts as well. If you look at this
Yeah,
distributions,
that's where I was taking to you. So the data visualization is so important, and that's give you a glimpse that how much the two data set is deviating from each other, and that is amazing thing is that that
exactly.
is, although there is like a minimal distance at a few data points at the density, but overall data distribution is
Yeah, I
captured.
would say there the deviation between the density is very minimal, but the pattern is again it's absolutely same. So you
That
can
is what is
see
important,
that is what
You
it is
know,
important. Yeah,
if I say that, let's suppose in a real case scenario, if I say that if I want to build a model and I want to do work with a third party, in these days, banks are working with different startups, different fintechs. So over there, to share the original data is to you have info security issues. So for that part, uh, because you want them to work on the real data, but you cannot share real data. So what is the solution? The solution is here. You can generate a data which has that data distribution, so that once they start working on the model, there is no difference in the model. So that model, you can rely that model and you can deploy that model in a real
exactly.
production environment, which can be built on synthetic data.
Exactly, and one more challenge most of the student faces is in academics, like they don't have an access of the real data. Most of the industries do not want to share their original data to the students so they can contribute in the research part. As we have also faced this challenge, like we want the data, we want the actual properties to do some research. So this GANs can also
Exactly,
help for
exactly.
the students as well.
That's where it very help in the
It's
academic.
really helpful, yeah. So you
So
can
further,
see it's
if you move,
amazingly,
I think none of the variable is much deviating.
yeah. And you can see the data type is also maintained. The GANs is actually able to maintain the quality of data as well. So it's only maintaining the patterns. It also measures the quality of your data. So this
If
is
you
data
come
set 2.
the
I think we
yes,
should
yes,
move on to the summary part, and then we can conclude this video because it's already took a lot of time. So let's discuss this summarized, and we can conclude our project. So this is the summary of the GANs, like how uh, it appears to show that how much deviation in the performance of machine learning models in both classification and regression. So we can see there is no such drop in the performance, a slight deviation that actually shows that your model is actually facing a small drift, but it is also showing that how resilient your model is to maintain your performance.
the only model where the data shows a little deviation from the original one is MLP, as we have discussed that part, that why MLP is a little facing a difficult to get that data. But overall, by far, for all the classification model, the support vector, the random forest, ADA both shows It's not much. Even though in the first one, if you see the breast cancer example, AdaVerse also shows a decline in the performance.
Yeah.
So that is fine. It's all about the objective, what objective you want to achieve from that data. Like in other case, in wine quality, it's not showing much deviation.
Yeah.
And similar to for the regression one, the weather one, you see that there is very, very minimal deviations.
And I would say regression is again one of the challenging tasks in machine learning as compared to classification. And we
Okay, one
are
more
amazingly,
thing to add with this summary, that there's one more application. When like in real world, we have faced that when we build a model on available real data, and once we deployed that model, after a few time, the performance deteriorated. So you can use this in such a way that you have of development data, and you can generate a fake data as well and make part of that with the development one. So
yeah,
you add some noise in the modeling side, and make a model, and then test that from a scenario that, so it can like be useful for a long time. You know, you have some future assumptions, you can have the future changes, you can incorporate that by a random way. So that's also can be an application of the GAN.
exactly. It's really helpful to combat against concept drift. And amazingly, we can see that the performance is good overall. And thank you, Rizwan. And that's all about the GANs and its application. So I hope you will enjoy this. You
Thank you,
enjoyed this.
Arman, and thank you, audience. So this is
We'll
an
come up
amazing
with
experience.
some more interesting videos, hopefully in future.